Okay, in this video, we're going to be talking about one of the most important um, applications of parabolic paths or parabolas, and that is projectile motion. When a bullet is fired, when an arrow is shot, when a missile is shot, when a basketball is shot, anytime you throw something, it follows a parabolic path. Goes up, comes back down at the exact same rate. It has that exact same axis of symmetry and all that. It's a parabola. So let's apply what we've learned now to projectile motion. Number one says a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. That's how fast it's traveling. The equation here gives the height after t seconds. So you can plug in 1, 2, 3, 4 and see how high it is after so many seconds. Plug in 0 and notice when you plug in 0 for the t, you get 0 for the h. Why? It's because it's kicked from the ground. 0, 0. At time equals 0, the height is 0. How many seconds will it take for the ball to reach its maximum height? Now, anytime you're talking about a maximum height, that's going to be the vertex of that parabola. So what you're looking for, and the easy way of finding this, since it's in this form, height is equal to negative 16t squared plus 90t. Anytime you're looking for the highest or lowest point, you can use your negative b over 2a formula. So therefore, let's just do that here. My b is 90, so you have negative 90 over 2 times negative 16 is negative 32. When you divide that out, I believe, let's see, you get 2.8125 seconds. Okay, so after that many seconds, it's going to reach its maximum height. So now, what is the maximum height? How do we find that? And let me put that answer over here where it's supposed to go, 2.8125 seconds. Well, we can just leave our answers here instead of putting them in the blank. You can put them over in the blanks if you would like. Let me just zoom in and we'll just write them right here. What is the maximum height? Okay, the height occurs at 2.8125 seconds. So what is the height at 2.8125 seconds? How do we find that? We simply plug it in. We're just going to do negative 16 times, plug that in for t, and plug it in for the t here. So you have negative 16 times 2.8125 squared plus 90 times 2.8125. And when you plug that into your calculator, you get 126.5625 feet. That is the maximum height of this ball following this projectile path. Okay, now here is a great example of domain and range and why it would be important. Now your domain here. Think about this. The domain would be the amount of time. This soccer ball, let me just right here. This soccer ball is kicked from the ground, goes up, and then comes down and hits the ground. Okay, your domain is just from the time when it's kicked to the time when it lands. Okay, so there's a couple of different ways we can find this. One method is we could take that negative 16t squared plus 90t, negative 16t squared plus 90t, and we could find out, okay, I know it hits the ground or is kicked from the ground at time equals 0, but when does it hit the ground again? What you can do is you can set the height equal to 0, and that's going to tell you when it's on the ground. So anytime you need to know when the ball is on the ground, set the height equal to 0 and solve it. This is going to be factorable. I can actually factor out, let's see, negative 16 and 90. I can factor a negative 2 out of that and then a t, and I'm going to be left with 8t minus 45 is equal to 0. Set each of those factors equal to 0. You have negative 2t is 0, 8t minus 45 is 0. Divide by negative 2 gives you t is 0. Add 45 and divide by 8 gives you 45 over 8, which is equal to 5.625, and those are in seconds. So we're only talking about it's on the ground at 0 seconds and it's on the ground at 5.625 seconds. Beyond that, we're not concerned with this function. So my domain for this function, I'm going to put it over here, the domain is from the time 0 to time 5.625. That's all we're concerned with. Now, another way that I was going to say that we could actually find that is you could have used this. It reached its maximum height after 2.8125 seconds. It's going to take the exact same amount of time to come back down. So you could have actually just doubled that and you would have got the same 5.625. Now the range now. The lowest that this ball goes to the highest that this ball goes here is going to be the range. And we know already the lowest is going to be 0. And we actually just found the highest. That's going to be 126.5625. And that's going to be the range of your function. Number 2, an apple is launched directly upward at 64 feet per second. And you can see the speed built into the formula here. This right here is actually the acceleration due to gravity, is where that negative 16 comes from. So that's where all of this stuff plays into the equation. The 80, we're about to see where that comes from. It's fired from a platform 80 feet high. So that's where that comes into the formula. And you'll get more of that when you deal with it in physics. The equation for the apple's height is given. What is the height after 3 seconds? So what are they asking you to find? What is h when time is 3? What's h of 3? So you're doing negative 16 times 3 to the second plus 64 times 3 plus 80. You're just going to simply plug that in and you're going to get 128 feet. That's how high it is after 3 seconds. Number 3, a toy rocket is launched from a 12-foot platform with an initial velocity, that's the starting speed, and we know that that speed actually slows down as it goes up. And oddly enough, once it hits its maximum height, the speed right here is 0. And then it starts speeding back up again. Okay, but anyway, back to the problem. 128 feet per second is the speed, initial speed. Its height, h, at a time t after the launch is given by the following equation. So obviously it's fired from a 12-foot platform, like we said. How long will it take the rocket to reach the ground? So this is the height of the rocket. And we want to know, when is the height of the rocket 0? Now, we know that we're not starting on the ground. We're starting 12 feet above the ground. So over the course of our domain, we're only going to have one value where it's equal to 0. And we'll talk more about that as we solve it. First off, I noticed that everything is divisible by negative 4. So I'm going to go through and divide every term by negative 4. That's going to now give me 4t squared minus 3t minus 3 is equal to 0. And from here on out, you can try, but this is not factorable. So since it's not factorable, we have numbers here and here. That's an odd number there and a number out front. So we're not going to use completing the square. So our best method is going to be quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we have our a, b, and c underlined there. I always start out with the b squared minus 4ac. So b squared will be 9 minus 4 times negative 3. That's going to be a negative 48. 9 plus 48 is 57. So that's the part that's under the radical, and that will not simplify, which it doesn't matter anyway, because we're going to get a decimal answer, because an answer like 2 plus the square root of 57 or something like that makes no sense in this problem. An application problem, we want a nice, neat decimal answer so that it's going to make more sense to us. So x is equal to negative b. B is negative 3, so negative 3 plus and minus that radical stuff divided by 2 times a is 2 times 4 is 8. So what we've got now, 3 plus root 57 over 8 and 3 minus root 57 over 8. Okay, and we can type this straight to our calculator. Now this is the important part. Type this in and make sure you get what I get. As you type this in, I put the whole top in my calculator and I find the answer to that. Then I take that answer and I divide it by 8. So when I do 3 plus root 57 and then I divide that by 8, I get about 1.32. Now let's see, that's in seconds. So after about 1.32 seconds, it has hit the ground. Well, why do I have a second answer? Why do I have 3 minus root 57 over 8? Let's actually plug that in and see what we get there. I get a negative 0.57. Now here's the thing though, that's not in our range. And the reason for that, if you were to actually, we're only talking about for this problem, time equals 0, which is right here, up to time equals 1.32. Our domain in this problem is 0 to 1.32. So this negative 0.57 is not even a time. And the reason for that, we shot this, let's see, what are we launching? A toy rocket. We shot it from 12 feet. It went up and it came back down. So if this were a complete parabola, yes, if we were to extend it over, it would cross over here at a negative value, but we're not concerned with this negative time because our time only ranges from 0 to 1.32. So after that 1.32 seconds, that's when it's going to reach the ground. So there is your answer. Number 4, a penny is dropped off the Empire State Building, which is 1,250 feet tall. The penny's path can be modeled by this equation. Height is equal to that. How long would it take the penny to strike a 6-foot tall person? So it's not hitting the ground. We're wanting to know when is the penny 6 feet off the ground. So negative 16t squared, which again comes from your gravity constant, plus 1250. When is that going to equal 6 feet? So we simply move the 6 over. So negative 16t squared plus 1244 is equal to 0. Now we should have noticed this a while ago, but since we're missing the b term, we're missing the how many t's there are. This is the easiest method here is going to be, let's solve by using square roots. So let's take our 1244 and actually move it back over and gives you negative 1244. Get rid of the negative 16 by dividing by negative 16, and that gives you that t squared is equal to 77.75, and then all we have to do to get rid of a square, we're going to do plus and minus the square root of 77.75, and we get plus and minus 8.18 seconds. Excuse me, that's supposed to be 8.818 seconds. However, think about this. We're talking about time. Think about your domain. The domain here is going to be, time is going to be from 0 up to whatever. In this case, it's 8 point. No, it's going to be further than that because it's going to strike the ground after that. So you have, for time, for this function, you have however long it takes to hit the ground, but you start at 0. That negative is not going to be in the domain is what I'm trying to say. So therefore, it's going to take 8.818, not a negative 8.18 seconds, but 8.818 seconds for it to hit a person 6 feet tall. Number 5, some fireworks are fired vertically into the air. Speed is 80 feet per second. The equation for this object's height and time is given. Find the domain of the function. So again, notice it's probably fired from the ground because it's plus 0. So here is, you got this firework launch, and we want to know what is the domain, or pretty much what's the time from here to here. So what we're going to do to find the domain is negative 16t squared plus 80t is equal to 0. We're going to see when is it on the ground. Because once it's on the ground, our domain does not go any time past then. This one's going to be very easy to solve by factoring. We're going to factor out a negative 16t. We're left with a t and a minus 5. Set each equal to 0, and you're going to get time equals 0 and time equals 5. So what does that mean? That's when it's on the ground, at 0 and at 5. So it took 5 seconds for it to go up and then come back down. By the way, they don't ask for it, but it would hit its height at 2.5 since it was fired from the ground. Now that's important. So therefore, the domain, the time is going to be from 0 to 5 seconds. We're not concerned with anything beyond that. The Apollo's chariot, a roller coaster at Busch Gardens, moves 101 feet per second. The height of the ride at time t can be represented by this equation. What is the maximum height? Okay, maximum height, we're simply looking for a vertex there. Vertex is found by doing negative b over 2a when it's in the standard form. So, and that's going to give us our normally x value, but instead of x, it'll give us our t value. So time when it reaches its maximum will be negative b over 2a, and that would be negative 101 over 2 times negative 16 is negative 32. which is going to be 3.15625 seconds. Now, did that answer the question? What is the maximum height? That's the time when it reaches the maximum height. So to actually find the maximum height, we're going to have to plug that into our function. The height at that time, 3.15625, we're going to take out every t. We're going to plug in 3.15625. So we're going to do negative 16 times that number squared plus 101 times that number. And this is, you can just type it straight into the calculator. I don't expect you to do these calculations by hand. Plus 10. And the height at that time is going to equal 169.391. And I believe that was in feet. Since this was in feet per second, then this would have to be in feet. And that is a rounded answer there. Okay, number 7. Eva is jumping on a trampoline. Her height at time t can be modeled by this equation. Reminder, initial velocity 20 feet per second. She's 6 feet off the ground. Will she jump a height of 14 feet? So a couple of ways you can do this. Probably the easiest way is to find the maximum height. And the way you can do that is just the maximum height occurs at the vertex. The time of the maximum height, and again, instead of x equals, it's t equals. The time of the maximum height will be negative b over 2a. So that's going to be a negative 20 over 2 times negative 16 is a negative 32. Typing that into our calculator, 20 divided by 32 is 0.625. So she's going to reach her maximum height after 0.625 seconds. So now to find out what that maximum height is, let's just simply find h of 0.625. And we can plug that in, take all the t's, plug in the 0.625, and just type that straight into your calculator. And you get about 12.25. And that's in feet. So will she hit 14 feet? No, her maximum height is 12.25. Now, the other way you could have done that is you could have said, okay, take out the h of t and plug in a 14. And you could have solved that equation. And if you would have tried to solve that equation, when is she going to hit a height of 14? You should have gotten no solution. There's no time when the height is equal to 14, and that's how you could have solved it that way. Number 8, a diver is standing on a platform 25 feet above the pool. He jumps with an initial velocity of 10 feet per second. Notice now they give us the formula, and we know already how to plug this in. V is the starting velocity, S is the starting point. We've already discussed all that. Write the equation. The height is going to equal negative 16t squared. Since the initial velocity is 10 feet per second, so you'll have plus 10t. The initial height is 25 feet, so plus 25. There's your equation. Find the diver's height after 2 seconds. That is simply what is h of 2. Plug in 2 for your time. So that's negative 16 times 2 squared plus 10 times 2 plus 25. That's going to be negative 16 times 4 plus 10 times 2 plus 25. That'll be a negative 64 plus 20 plus 25, which gives you, let's see, 45 minus 64, negative 19. And that's odd. How would you have a height of a negative 19? What does that mean about our formula here? If he's below the ground, well, that means he's already hit the water. So that's probably beyond my domain. 2 seconds, it probably didn't take him quite 2 seconds to hit the water. So that was probably going to be outside of my domain. Okay, the last one, number 9. Astronaut on the moon throws a baseball upward with an initial velocity of 10 feet per second, letting go of the baseball 2 meters above the ground. The equation of the baseball's path can be modeled by h of t equals negative 0.8t squared. And you notice the initial velocity and the height there, but this has changed. Now, the reason that has changed is we're actually talking about meters per second squared now. We're not talking about feet per second squared, so therefore that's the reason the constant is different. He does the same experiment on Earth, and here is the height formula for Earth. How much longer will the baseball stay in the air on the moon compared to the Earth? So we're going to need to know how long is it going to take this baseball to hit the ground. So let's take our, let's start out with our Earth model or moon model here, negative 0.8 t squared plus 10t plus 2. And we want to know when will it hit the ground. When is the height equal to 0? Now, first off, I noticed something that a lot of people have issues with. They don't like that decimal out front. Let me show you a trick here. Remember back in elementary school, if you had like 0.35 and you needed to multiply by 10, that you could just move your decimal over to multiply by 100, move it over again? If you want to get rid of this decimal and not have to work with decimals in this, take your whole equation and multiply everything by 10. And that's going to move this decimal over. It's going to change it for all of it, but that's fine. Then you get rid of that decimal. That's going to be negative 8t squared plus multiply by 10 will be 100t, and then plus 20 is equal to multiply the 0 by 10 as well. It gives you 0. And that looks a whole lot better. And you could even go through, if you wanted to work with smaller numbers, because this is not going to be factorable. This is a real-life equation. Real-life equations are rarely ever factorable. Let's go through and multiply everything by negative 4, because we're going to have to use our quadratic formula anyway. That would give us smaller numbers. Divide everything by negative 4 gives me a 2t squared, a negative 25t, and a negative 5. So it gives me a little bit cleaner equation. So I want to know how much time is it going to take for this to hit the ground. So let's solve this equation. We are going to use the quadratic formula. So let's start out with b squared minus 4ac, our discriminant. B squared be negative 25 times negative 25, which is 625, minus 4 times 2 times negative 5. 4 times 2 is 8, times negative 5 is a negative 40. That's going to be 665, and again, that is what's under your radical. So now let's plug that into our quadratic formula. X equals, or in this case, t equals, negative b, which would be 25, plus and minus the square root stuff, 665, over 2 times a, and a is 2, so 2 times 2 is 4. Let's plug both of those in and see straight to our calculator. We don't want to simplify the 665 because it's going to, we're wanting a decimal answer anyway, so let's plug it into our calculator, see what we get. I got 12.7 and negative 0.2. Now, we're talking about time here, so we're going to throw out any negative time. So it's going to take 12.7 seconds for it to hit the ground that was on the moon. Now, let's do the exact same thing with our Earth model. We have negative 4.9 t squared plus 10t plus 2, and we want to know when is the height 0. You can do the same thing, multiply everything by 10, gives you negative 49t squared plus 100t plus 20 is equal to 0 if you don't want to work with the decimals. That equation, you cannot reduce it, so therefore let's go ahead and find our discriminant. B squared minus 4ac. B squared is going to be huge now. 100 times 100 is that big. Minus 4 times A times C gives me negative 3,920. Minus minus makes a plus, so that'll be 13,920. And again, that's going to be the stuff under your radical. And again, since we're using it with a calculator, it really doesn't matter how large the numbers get. It's still pretty simple. So the time that it's going to take is now negative b plus and minus the radical stuff. And if you think about it, more than likely you can throw out the minus there because that's going to give you that negative answer. Possibly. Sometimes you might have to throw out the plus. Over 2 times a, which is a negative 98, which I do think you're going to have to throw out the plus one here. So let's type both of those in and see what we get. And here are my two answers. And this was the answer I got for the plus sign and the answer I got for the minus. The reason for that, you had the two negatives divided by negative, and that's why you got the positive there. So we're going to throw this answer out because of our time. We're dealing with only the positives. And this is in seconds. So on the moon, it took 12.7 seconds. On Earth, that same initial speed, the gravity wasn't pulling down near as much on the moon. So it only took 2.2 seconds for it to hit the ground on the Earth. So it took 10.5 more seconds for it to hit the ground, and I believe that's what it asked. How much longer would it take, or would the ball stay in the air on the moon compared to the Earth? And again, that would be 10.5 extra seconds.